everyone, welcome back to my channel. So this is the sixth video in my playlist Microsoft Agent Framework, and we will see how we can get started with workflows. So workflows are like a pretty hot topic these days, and everyone is talking about workflows. How can we streamline our process? How can we make our agents call to each other? So all these are part of this workflows video. So we will start by understanding what is workflow. How is it different from AI agent? Then I will show you what all different kinds of workflows we can create, and at the end we will see the code written in Python about all of these workflows. So first let's understand what are workflows. So workflows in Microsoft Agent Frameworks are provides you a structured way using which you can build smart systems that can do real things for us. So when I'm saying real things, that means like sending messages, updating your tickets, updating your dashboards, making a call to API, or making a call to some custom functions which you have written, and everything will be done in a particular order. So you don't need to worry about the complicated setup or the technical stuff to sequentialize or to arrange them in order, but workflows will take care of them. So just focus on what you want to do with your AI, and the workflow will take care of the steps part. So that's why I'm saying here, smart steps your agent follows to complete real tasks without making any complex setup. So it means you just focus on what needs to be done, and how it has to be done will be taken care by the workflows. Now there is a major difference between AI agent and workflows. So don't get confused between these two, because workflows are not AI agent. Though they look similar, but they serve very different purposes and operate at completely different level of abstraction. So when we're talking about AI agent, then AI agent is typically driven by LLM, because without LLM we will not say it is an AI agent. So for an AI agent there will be an LLM, and it will have access to various tools to accomplish different tasks. Now the steps an AI agents can take could be dynamic, or it can be determined based on the LLM's output, based on the context we are providing, and based on the tools we have available for the entire setup. Whereas workflow is a little bit different than what we are doing using agents. So workflow is a predefined sequence of operations that are designed to handle the complex business problems. So now when I'm saying complex business problems and the components and the operations, these all can be an agent. So workflow can include AI agent as a component as well. So it means whenever you want to design a workflow, you can design it with AI agent with LLM or without LLM. So these are the key differences. So do not get confused between AI agent and workflows. You can still create smart workflows without using LLM, which I will show you in a while. Let's take a quick look at the key terminology which you need to understand before moving forward. So this small picture which you can see on my screen here, like 3 boxes, few arrows. So these white color or the cream color boxes are called executors. So executor, you can consider it as a individual processing unit which is part of your workflow. So workflow consists of lot many executors. So these executors would be your processing unit which can run any custom logic, or it can be an AI agent which will receive input, which will spit output, which will perform specific task, which will produce output based on your given data type or the structured way you want. So that's what executor is, that individual unit, processing unit. Then we have edges. So edges, you can see in the screen, that's a blue color arrow marks which are pointing towards the next direction for the executor. So you can think edges as the connections between the executors. So it determines the flow of your messages depending on our use case, depending on what are the conditions we have kept in between, because it's not necessary that you will always call your workflow in a sequence, or you will always call executors one by one. It completely depends on your business logic, completely depends on your use case, like whether you want to call multiple executors at once, or whether you want to call a specific executor depending on the given condition. So edges will play that role, that when to call which one. And then coming to the workflows, so this entire picture, I would say you can consider it as a workflow. So these are the directed graphs which are composed of edges and executors. So basically workflow defines the overall process of what we are trying to achieve, starting from our initial executor, then proceeding through various paths based on the conditions or the logic we have defined on our edges. So this is all workflow. This is all about the workflow. And here you can see the bottom I have placed a few lines of code over here just to give you an idea what exactly this workflow is all about. So here you can see at the first line I have written the executors. So executor is the decorator which you need to put or place on top of your function which you want to consider as an executor. So there could be hundreds of functions in your file, but you don't want those all hundreds of functions to be the executor. There would be hardly one or two executor, but rest functions could be your helper functions. So in that case, whichever the main function which you are saying that the individual processing unit can be decorated as an executor. So in this case, like I have an executor named explain text, and it is having a unique ID which is explainer executor. So one of these white boxes will be the explain text executor, and it will just take some dictionary as an input, will do something and will spit some output which is in the form of string. So this is the first thing. Second thing is either you can go with the asynchronous or you can also go with the synchronous. It truly depends on your business scenario. Like if you don't want your UI to hang or you don't want your UI to stuck, then async is always the good way to go for that. So go with async. Then the next thing is the parameter. So in this case, dictionary is my input parameter, and then you can see another parameter which is workflow context. So what this workflow context does is it handles the interaction within the workflow. Like let's say you want to take output of one executor and then pass it on to the other. That would be done using the CTX, which is workflow context. And here it is taking like two parameters. Sometimes it could be one, sometimes even you can skip it. So the first parameter here would be, the second parameter would be the return type, and the first is whether it is going to give its output to somebody else, I mean to some executor or not. So if this is the last, then it will just pass, we will just pass never here. Then in between we are doing some processing, and as the last line you can see await CTX yield output. So here we have two important functions. One is send message and another one is yield output, which I am showing over here. So use send message whenever you want to send data to downstream executors, whenever you want to pass your output to some other executor. But when you don't want to do that, then you have to use yield output. And what this yield output does is it will send the output back to the workflow caller who is calling this particular executor. So make sure that you are making a call whether either using send message or using yield output depending on your scenario, and accordingly you need to pass the parameter in your workflow context, whether it is never or it would be something else. So these are the few things which you need to keep in mind, and I think with this much of knowledge we can get started. But before that, let me show you one last slide, which is like the types of edges. So there are different types of things which we can handle, but just thinking about these few, I think we can make almost every scenario. So the very first one is the direct edges. So direct edges is just one-to-one simple connection between two executors. Then we have the conditional edges. So conditional means you need to invoke some other executor based on the given condition. So if your condition is satisfied, then only workflow will go ahead and make a call to that executor. So again, either you can go with the if-else statement or you can also go with switch case. I will show you both of these in next few minutes. And then we have a fan in and fan out edges. So whenever you want to work with the scenario wherein you want let's say you have one executor sending a message, but there are multiple recipients, which are also known as targets. So when you have one executor sending messages to multiple targets, then it is known as a fan out edges. But when the scenario is reverse, where multiple executors are sending messages to a single target, which means they're aggregating the result, in other words, so that is called fan in edges. Now the fan in edges needs little bit more work. It's not that straightforward to implement. So perhaps I will cover that in my next video, but rest all I will show you with a very, very easy example. So let's get started. So I'm on my VS Code, and the very first thing you need to do is you need to install this package, which is Agent Framework. So once this is installed, then you must have seen this code earlier in my very first video of the same playlist, where I have just introduced you at a very high level the basic workflow. So this code is still the same, I just tweaked it a bit. So what I'm doing here is I have created 3 executors. One is the parse text, then I have convert text, and the third one is the explain text. So the parse text is the very first one which will be invoked, and what it does is whatever the string we are giving. So let's say in this case I am saying convert 110 degree Fahrenheit to Celsius and explain how. So there are multiple things which we are doing here. So the very first step is extracting the number. What is the number you want to convert? And then you also need to extract whether you are going with Fahrenheit to centigrade or centigrade to Fahrenheit. So this particular Python code is straightforward, just the simple parsing, which you can write it by your own as well, nothing fancy here. But what I'm trying to extract here is these parameters: the number, from which unit you want to convert, and to which unit you want to convert. So this all hard coding logic is just for that. And once I'm able to do that, I'm constructing the result, which is in the form of a dictionary. So that's why you can see here my workflow context is dictionary, because this is what I want to pass on to my next executor. So once I have this dictionary ready with value to and from, next I'm going to pass it to the converter text. So this converter text will take care of that conversion, whether centigrade to Fahrenheit or Fahrenheit to centigrade. So it will convert that, and then it will give you converted variable, you can say. So this converted variable will have the final output. Now we have this output. Next what we are doing is we are passing this entire information to explain text. So what it will do, it will just grab the calculation or whatever the user is asking and will give you in a proper, I would say, the words, or it will frame it nicely, because I am asking it to convert it and then explain it. So these are the 3 executors I have created. Next thing is I am creating a workflow. Now this is the example of a very simple workflow, and here I am saying add all the edges. So the very first edge I am adding is parse text. It will pass the information to convert text, and then convert text will pass it to explain text. So these are the 3 executors I am covering by adding the edges, and then I am saying which one is the first one. So of course in our case it would be the parse text. So once this workflow is built, it is as simple as making a call to any function. So here I am just saying run stream, and this is my user's question or the query. So let me quickly try this out. So I need to so now it will go ahead and give you the proper output with all the events which are executed in between or triggered in between. Now what all events, let it come here first. Okay, so here you can see these are the various events. So if you don't know what all these events are, I would recommend you to go and check out my first video, because there I have elaborated these events a bit. So I'm not going to repeat again, but let's see what we are doing here. So here it is saying complete successful, and 110 degree Fahrenheit is approximately this, and to convert Fahrenheit to Celsius, subtract 32 and multiply by 5/9. So this is what the explanation is. We are saying that explain. That's the reason it is also providing you how it was calculated. And this is the very simple workflow in which we have created 3 executors. Now let's move on to a little bit more complex one, which is conditional. Now here I have kept this parsing logic as it is, and now when I'm saying conditional, it means edges that only activate when certain conditions are met. So keep this in mind. And again, I'm not doing any change in my this convert. So what I'm doing here is, to keep it simple, I have just added one edge here, and I'm saying start with parse text and then make a call to convert text, but make a call only when my value is greater than 5. Okay, now how this value is coming is, here you can see it is flown from here. So this is the value. Now let me go ahead and show you how it works. So this time my file would be conditional. So I'm saying convert 100 degree Fahrenheit to Celsius and explain how. So let's see how it is. So it is saying it executed value is 100 from F to C, converted this. So it means it was able to convert this 100 degree because my value was greater than 5. Now let's change it to something else. Let's make it 0 and see how it behaves. It is still 37.8. Maybe we can give some large value. Yeah. So this was the perfect example. So whenever I am giving this particular condition, that whenever my value is greater than 300, then only go ahead and make a call to convert function. But in this case, as it was, the condition was not meeting, that's why you can see that the particular executor was not even invoked. Otherwise, you would have seen the message something like this. So this is how we can handle the things conditionally. Depending on our use cases, we can set this condition to whatever we want. Let's move on to the third one, which is switch case. Now for switch case, let's close this. For switch case, what I have done to make it a little bit more simpler, I'm not using those convert text and all. Rather, I have created a very simple one. So this is my one executor, which is just giving you the successful message. Then I'm having another executor which is giving unsuccessful, and then the default case, which we usually handle whenever we are dealing with switch case statements. So these are the 3 things, and I still have the parsing one, because this is the one who is going to take care of my string or the data extraction part. So now what I'm doing here is, before that you can definitely read this particular line. So you can use switch case edges between executor when edges that route to different executors based on the output of the previous executor. So basically it's a conditional one, the same thing, but it's in a little bit more different way. Now this is my first executor. Then I'm setting up the edge that who is going to call what. Then I'm creating the switch case statement over here, depending on the convert text. So I'm saying if my value is greater than 45, the converted value, if it is greater than 45, then make a call to this executor. If my value is this and this condition is meeting, then make a call to this executor. So target is nothing but the executor which you want to invoke depending on these particular conditions. And when none of these are meeting, we can just go with the default text, which is this one. So let's quickly try out few values. So I have written here a few examples so that we don't spend much time. Let me execute this here. So here I have given that 110 degrees. So whenever you are converting 110 degree Fahrenheit to Celsius, you will get something like 43.33. So this 43.33 is falling under this category because this is false, so it will not be invoked. This is true because 43.33 is 44 is greater than 43 and it is greater than 0, so this will be called. And here if you will see my unsuccessful, it is saying the output as conversion didn't go well. So that's what we got it over here. Now let me show you one more thing. So I can make it 205. So this is very simple condition, but here you can see I have also added AND. Okay, so in this case you can see this time my message was conversion successful, because whenever we are giving 205, it will convert it to 96.11, which is this condition. Now if you are going 0f, it will give you negative, which means it is not going to meet any of these conditions, and we will end up with default text executor. So this is what we have. And one more thing which I want to show you is fan out. So fan out between executors. So it says that edges that allow multiple executors to run in parallel from a single executor. So it means there would be one executor which can execute or which can invoke other executors. So let's collapse this one. And here I have created these 3 executors. So whenever my parse is called, I want to pass that information to like these 3. So this is how you can set it up. This is my very first one, which is the starting point. Then I need to add all the executors which I want as a fan out edges. So in this case I am having these 3, so I have added these 3. If you have more, you can definitely add it and just make a call to this. So let me show you how this particular scenario is working. So in this case, what I have given is 110. Let me show you from, so it started from here and it completed the result. So here you can see one output is conversion successful, then we have didn't go well, and then we have the third one, which is I am dummy value. So these are the 3 executors which got invoked as soon as this one was done. So this is how you can just call one and you can set multiple as a target basically. So executor is one, I would say the initiator is one, but the targets are multiple. So all these are receiving the output which is generated by the parse text or the very first one. So if you want, you can add few more here. You can add different fan out edges as well. So that's all I have for today. Now here in all these examples, I am taking bare minimum or very simple code which is written in plain Python. But if you want, you can also try the similar logic with the LLM as well. So you just need to push in your LLM code here instead of the hard-coded string. So if you want to see how we can use workflows with LLM, do let me know in comments and I can come up with another video for that. So till then, stay tuned and do let me know in comments how is it going with you. Thanks for watching.